Okay, so we're now on part 2 of the transformation by trigonometric formulas. So this is a continuation of our discussion last Wednesday. So last Wednesday, so we covered 3 cases. So particularly, those are the trigo or the integral, okay, so of product of sine and cosine. Okay, so whether the exponents are odd or even. Okay, so case 3, so it's a product of sine and cosine. So we're in either of the exponents of sine or cosine is odd number, odd integer. And then for the case 2, so case 2 suggests that that would be a product of sine and cosine. However, so that is for an even, okay, so for even integers. And then for angle of sine and cosine, so which is not the same, okay, so we have the case number 3. So for case number 4, 5, and 6, so case 4 is all about product of, or case 4 is about tangent and cotangent. So case 5 is about secant and cosecant. And the last one would be the product, okay? So of either tangent and secant or secant and cosecant. So for case 4, it's not a product, okay? So it's just the integral of a tangent whose exponent is more than 1. Okay, so in this case, that is the tangent raised to m, or tangent u raised to m du, then the other one is cotangent m, or cotangent u raised to m du. So this one, regardless, okay, so as long as the exponent, okay, so as long as the exponent is positive, whether that is odd or even, so this would be the transformation that we're going to do. So we're going to subtract 2 from m, okay, so we're going to subtract 2 from m, and then so we're going to retain the tangent squared. So for example, if we have the tangent to the fourth x, so we transform that one as the integral of tangent to the fourth. So tangent, so 4 minus 2, that would be 2x. And then we retain the tangent squared x dx. So if it is tangent to the fifth x dx, so that would be, so we subtract 2, that is tangent cube x, and then we always retain the tangent squared x dx. And then after that, so the same as true with cotangent, it's still the same thing. Okay, so it's whether that is tangent or cotangent. And then afterwards, so we're going to replace. So what are we going to replace? So we're going to replace the tangent squared. So this one. Okay, so we are replacing this 2 secant squared u minus 1, or if it is cotangent, that would be cosecant squared u minus 1. So we are transforming it to secant squared u minus 1, because remember, in integrals of basic trigo function, so we have the integral of secant squared u du. So which is, that's the integral of secant squared u du. So we have a direct integral of secant squared u du. So which is, anyone? Tangent. Okay, so it's tangent. Okay, so tangent u plus c. Okay. So we are transforming that one to secant squared u kasi nga meron siyang direct integral. So if it is just a secant squared u, that's tangent. However, if it is multiplied it with tangent, then we can use the power formula. Okay, so that is for case 4. So let's have this example number 1. So 3 tangent cube 2x dx. So this is case 4. So we use the coefficient rule. So we move out 3. And then the tangent cube 2x dx. So we subtract 2. So that would make it 3 minus 2. That is just 1. So tangent 2x. And then multiply it with tangent squared 2x dx. As you can see here, so 1 plus 2, that would still be 3. So that would make it tangent cube. Okay, so 2x. Then afterwards, so we substitute. So what are we going to substitute? So we're going to substitute the tangent squared. What we have actually is the tangent squared u. So that is the same as the second squared u minus. Okay, so minus 1. But since our u here it's 2x, so tangent squared 2u or 2x, then this would be equal to second squared 2x minus 1. And that is what we are going to substitute here. So 3 integral of, so we retain the tangent 2x and then the tangent squared. So we're going to have second squared 2x and then minus 1 dx. And then, so we distribute. So that is 3, the integral of tangent 2x, multiply it with second squared 2x dx. And then, so we distribute this one here. So the second one is to the negative 1. It is minus tangent 2x dx. Tanggalin muna natin ito. And then, so we perform the sum and difference rule. So this is the same as 3 tangent 2x times second squared 2x dx. And minus 3, the integral of tangent 2x dx. So just like in case 1, 2, and 3, so whenever there is a product, so whenever there is a product of two trigo functions, that means we're going to use power rule. While if it is just a simple, it's just a single function, okay, and then you can integrate it. So we can just use the basic trigo function integral. So in this case, so what should be our u here? So for the first term, what should be our u? The tangent 2x second squared 2x dx. So we can use power formula here. For the second one, so it's easy. So tangent 2x, our u there, it's 2x. So how about for the first term? So we will be using power rule here. What should be our u? Tangent. Okay, so very good. It's the tangent 2x because once we derive this one, so we'll be able to get the second squared. So the derivative of tangent 2x is second squared 2x. But we derive 2x, that is 2 dx. So ito, ang u natin, it's just 2x, so derivative, it's 2 dx. So now, we use our formula. So what's the formula? So that would just be power rule for the first term, and then the integral of tangent for the second term. Okay, so we have the integral of u raised to n du equals to u raised to n plus 1 all over n plus 1 plus c. Now the other one, we have the tangent u du, so which is the same as ln of second u plus c. So now, we write 3, then the integral, so it's u. Ang u natin, it's tangent 2x. Ang n natin, it's 1. Okay? So, bayaan lang natin. Then we have our du. So our du is this. So which is second squared 2x times 2 dx. So we are in excess of 2. So therefore, we divide this one by 2. Or we neutralize it. Okay, so by multiplying it with 1/2. And then afterwards, so we'll have minus 3, then the integral of, so this time, so we have the tangent u. So tangent, our u is 2x, du is 2 dx. So we are in excess of 2, so therefore we neutralize it by 1/2. So thus we can now integrate this. So for the first one, we use the power rule. So 3 all over 2. So multiply it with this one. So u raised to n plus 1. So tangent 2x, our n is 1. 1 plus 1, it's 2 all over 2. So that is for the first term. For the second term, so minus 3 all over 2. So multiply it with, what's the integral of tangent 2x? So this is the formula. That is ln second u. So our u is 2x. And then plus c. So finally, our answer would be 3/4 of tangent squared 2x minus 3/2 of ln of second 2x plus c. And this would be our final answer. So that's how we do it. Okay, so for tangent only. Okay, so with an exponent of, the exponent is add. Question. Yeah. Okay. Let's proceed with the second example. The second example, so it's an even. Okay, so even yung exponent niya, but it is cotangent. So 3 theta d theta. So we equate this one, so equal to, so we want a cotangent squared. So that would be cotangent then, so 4 minus 2, it's 2. And then 3 theta, so multiply it with cotangent squared 3 theta d theta. So that is our integrand. So it's a product of cotangent squared 3 theta. And then, so we replace the cotangent squared 3 theta, so which is cosecant squared 3 theta minus 1. Okay, so that's the identity that we will be using. So cotangent squared 3 theta is equals to cosecant squared 3 theta minus 1. And then, so we substitute. So cotangent squared 3 theta, then multiply it with cosecant squared 3 theta minus 1 d theta. Then we distribute. So that is cotangent squared 3 theta, cosecant squared 3 theta. So we distribute this first, then the second one to the negative 1. Then minus cotangent squared 3 theta. D theta. Okay. So afterwards, so we can use the sum or the difference rule. So that would be cotangent squared 3 theta d cosecant squared 3 theta d theta, then minus the integral of cotangent squared 3 theta d theta. So what is our u for the first term? Kamukha niya lang yung kanina. So it's cotangent. So very good. So it's cotangent. So yung cotangent, 3 theta lang. So huwag mo isama yung angle. Okay? So kasi magpa-power rule tayo. So the derivative of cotangent 3 theta, that is negative cosecant squared 3 theta, and then we derive the 3 theta, so that is 3 d theta. Okay, so d theta. And then for the other one, so cotangent squared has an integral, right? So, but our u here, it's 3 theta. So our du would be 3 uh, d theta. So d theta. So now, so what are we going to use? So for the first one, so we use u raised to n du, u raised to n plus 1 all over n plus 1 plus c. The second one, so we use the cotangent. Okay. So cotangent squared 3 theta. 3 theta. So what's the integral of cotangent squared 3 theta d theta? Or sorry, the formula. Sorry, it's formula. It should be u. So cotangent squared u du, it's the same as ano ba ginawa ko? Cotangent. So cotangent squared, okay, so its derivative is cosecant. However, for cotangent, cotangent does not have a direct integral. Okay, so it's just like here. Rather, we still be needing an identity. Okay, so the identity for cotangent squared is this one. So the cotangent squared 3 theta is equals to cosecant squared 3 theta minus 1. So we still need to transform that one. Going to move this here. So yan. So ito meron na. No? Pero ito, so we need to transform this one into the integral of cosecant squared 3 theta minus 1 d theta. Okay. So cosecant squared 3 theta minus 1 d theta. And then, so this should be the same as the integral of cotangent squared 3 theta cosecant squared 3 theta d theta, then minus the integral of cosecant squared 3 theta d theta, then negative and negative 1, that would be positive, the integral of d theta. Okay? So we still need to transform the cotangent squared. Kasi wala siyang direct integral. It is the cosecant squared that has the direct integral. So the integral of cosecant squared, okay, so u du, so that would be equal to negative cotangent u plus c. So yung kanina secant, ay tawag dito, tangent. No? So this one is cosecant squared. So now, so we can rewrite this one. So we have, we'll be starting with this. So our u, it's cotangent. So it's cotangent. Our n is square. Okay. Then our du, so this is our du. So multiply it with 3 theta. Then multiply it with negative cosecant squared 3 theta. Multiply it with 3d theta. Okay, so that's our first term. And then what is in excess there? So comparing the two, so we have cotangent squared and cotangent squared, then cosecant d theta, cosecant d theta. So we are in excess of negative 1/3. So we multiply this one by negative 1/3. And then, so minus the integral of, for cosecant, so we use this one, cosecant squared 3 theta. Then our du, so du is, so since our u is 3 theta, so our du is 3d theta. So therefore, we multiply this one by 3d theta. And then, so we are in excess of the 3 here. So we neutralize it by 1/3. And finally, we have the plus the integral of d theta. So our answer then would be negative 1/3. So we use the power rule. So this one, so u raised to n plus 1. So cotangent, so 2 plus 1, it's 3 all over 3. And then for the second one, so negative 1/3. So the integral of cosecant, it's negative cotangent of 3 theta. And then plus the integral of d theta, it's theta plus c. So finally, our answer would be negative 1 over 9 cotangent cube 3 theta. So or plus 1/3 cotangent 3 theta plus theta plus c. So that will be our answer then. So negative 1 over 9 cotangent cube 3 theta. So plus 1/3 cotangent 3 theta plus c. So that is for case number 1. Question? Clarifications? Okay, so let's proceed with case number 5. Okay, so for case number 5, that is when both are positive integer, pero m is even. Okay, if the exponent is even. Yung kanina, when the exponent, that's for tangent and cotangent. This time it's for secant and cosecant. So what we have here is when m is even. We don't have, or when m is odd, so we use integration by parts, so which is beyond our lesson. Okay, so we'll be discussing that one. So once we proceed with methods of or other integration techniques, so which is integration by parts. So that's why our example this time will just be limited to when m is even. Okay, so when m is even, so what we're going to do is we subtract 2. Okay, so from the exponent, parang kamukha na lang yung sa case 4. So we subtract 2 and then we retain the second squared u. But this time around, ang papalitan natin is yung sinubtract natin. Okay? So the one that we're going to replace is yung pinagsubtrakan natin. Hindi kamukha nung kanina. So going back here, so ito yung pinagsubtrakan natin, pero ang pinalitan natin is this one. Okay? So it's the tangent squared. Okay, so yun yung papalitan natin sa case 4. Sa case 5, baligtad. Ito ang papalitan natin. Okay? So the one that we're going to replace is this. Okay, yung pinagsubtrakan natin. Kasi we want na maging tangent yun. Kasi nga, so the derivative of tangent is secant squared. The derivative of cosecant is, or the derivative of cotangent is cosecant squared. Okay. So we are just limited to when m is even. So wala tayong example na magiging add yan. So pagdating natin sa integration by parts, so that's the time that we will be discussing that. Okay. So example, so we have the integral of 2 secant squared to 2t dt. So we move out 2, and then for the second to the 6th 2t, so we subtract 2, so that is 6 minus 2, that will be 4. So second 4 2t, then multiply it with secant squared 2t dt. So 4 plus 2, that would still be 6. Okay. Then afterwards, so before we can use our identity, so our identity is secant squared. Okay, so our identity is secant squared. So we need to transform this one into secant squared 2t, and then that would be raised to 2. Okay, so secant squared 2t raised to 2, because our identity is secant squared. Okay. And then we retain the secant squared 2t dt. So we transform. So what is the value of secant squared 2t? So secant squared 2t, it's the same as tangent squared 2t plus 1. Kanina baligtad. Tangent squared is secant squared minus 1. So this one is tangent squared 2t plus 1. Then we substitute. So 2, the integral of, so tangent squared 2t plus 1, and then raise it to 2. So multiply it with secant squared 2t dt. So tangent squared 2t plus 1 squared, and then multiply it with secant squared 2t dt. Then afterwards, so we need to expand. Okay, kasi there's a raised to 2 there. So the expansion of this, so square the first term, so that would be tangent to the fourth 2t, and then plus twice the first term, so tangent squared 2t times 1, still be 2 tangent squared 2t, and then plus 1. So for the second term. And we multiply it with secant squared 2t dt. So this time, so we're just going to distribute this to the 3 terms. Okay. So diretso ko na to, no? So this one will become then 2, the integral of tangent to the fourth 2t multiplied with secant squared 2t dt. And plus, so 2 times 2, that is 4, the integral of tangent squared 2t secant squared 2t dt. And lastly, we'll have plus 2, the integral of secant squared 2t dt. So this one, so since the secant squared 2t dt, that's the du. So our u here, so for the first term, will be the tangent 2t. So the same as true for the second term. Di lang sila parehas ng exponent. One is 4, the other is 2. Pero for the second term or the last term, so this is secant squared 2t. So it's just a single trigo function, and there is an integral for secant squared. So therefore, our u is just 2t. So derivative of tangent 2t, that is secant squared 2t. So derivative of 2t, it's 2 dt. And then du will be 2 dt. So we use the formula u raised to n plus, or u raised to n du is equals to u raised to n plus 1 over n plus 1 plus c. While the integral of secant squared u du, that's the same as tangent u plus c. Those are the formula. So now we'll start with the first term. So that is 2. The integral of, so u raised to n. So u natin, it's tangent 2t. Ang n natin, it's 4. Okay. And then our du, so the derivative is this one. So the derivative is secant squared 2t times 2 dt. So we are in excess of only 2. So therefore, we divide it by 2. And then, for the second term, so we have plus 4. The integral of, so our u, it's tangent 2 or squared 2t. Then the derivative, it's the same. It's secant squared 2t times 2 dt. And then we are in excess of 2 again. So therefore, we divide it by 2. And lastly, so we have plus 2, the integral of secant squared 2t. So it's du, Ito yan, secant squared, and then du natin it's 2 dt. So we are in excess of 2, so therefore we divide this one by 2. So 2 divides 2, that is 1. And then we apply the power rule. So that is tangent to the fifth 2t all over 5. And plus, so 4 over 2, it's 2. Multiply it with tangent. 2 plus 1, it's 3. 2t all over 3. And then 2 over 2, it's 1. Then integral ng second, it's tangent u. So tangent, ang u natin, it's 2t. So tangent 2t plus c. So finally, so the answer would be 1 over 5. So tangent to the fifth 2t plus 2/3 tangent cube 2t plus tangent 2t plus c. So 1/5 tangent to the fifth 2t plus 2/3 tangent cube 2t plus tangent 2t plus c. So 2 seconds dito. Question? Let's proceed. So what if I have cosecant to the fourth? So again, cosecant, and then it's even, so that is case 5. So for this one, that would be, so we subtract 2 again. So cosecant squared theta over 2. And then, so cosecant squared theta over 2 d theta. So cosecant squared theta over 2, cosecant squared theta over 2 d theta. And then, anong papalitan natin? So this one. So the cosecant squared theta over 2, it's the same as cotangent squared theta over 2 plus 1. Okay. So we substitute that. So that will be cotangent squared theta over 2 plus 1. Then that is multiplied to cosecant squared theta over 2 d theta. Then we distribute. So that would be, we distribute this term to this. So that is cotangent squared. So theta over 2. So multiply it with cosecant squared theta over 2 d theta. And the last one, so we distribute this one here. So plus the integral of cosecant squared theta over 2 d theta. So this time, our u, so power rule ito, no? So ang u natin dito is the cotangent theta all over 2. So our du will be cosecant squared theta all over 2 negative. And then what is the derivative of theta all over 2? It is 1/2 d theta. Kasi theta over 2, that's just the same as 1/2 theta. So therefore, its derivative would be 1/2 d theta. So yung isa naman, so since nag-iisa lang yan, ang u natin is theta all over 2. So therefore, its du would be 1/2 d theta as well. So now, so again, the two formula that we will be using, u raised to n du, plus u raised to n plus 1 over n plus 1 plus c. The other one is cosecant. So cosecant squared u du, that's the same as negative cotangent u plus c. So we use the format. So u, which is cotangent theta all over 2. Our n, ito yung n natin, it's 2. du. So the du is this. So negative cosecant squared and theta all over 2 times 1/2 d theta. So what is in excess here? So we don't have the negative, and at the same time, we don't have the 1/2. So neutralize that one. So 1/2 divided with 1/2. Okay. Or sorry, we neutralize 1/2 by multiplying it by 2. So instead na magdi-divide tayo, this would be equal to negative 2. And negative 2 times negative 1/2, that is just 1. Okay? And then for the second one, so we have plus integral of, ito, cosecant squared. Ang u natin is theta all over 2 du. So this is our du. Multiply it with 1/2 d theta. But then, so what is in excess? This 1/2. So to neutralize that, we multiply it by 2. So 2 times 1/2, that is 1. So now we can now integrate it. So negative 2, multiply it with this formula. Our u, it's cotangent theta all over 2. Our n is 2, so 2 plus 1, it's 3 all over 3. And pangalawa, then plus 2. So 4 cosecant. So ito siya, negative cotangent. Negative cotangent. Ang u natin is theta all over 2. Then plus c. So our final answer then would be negative 2/3 cotangent cube theta all over 2 minus 2 cotangent theta all over 2 plus c. So negative 2/3 cotangent cube theta all over 2 minus 2 cotangent theta all over 2 plus c. And that's the last example for case number 5. Okay. So just go back so with our discussion. So we'll try to finish this one. We have case number 6. So case number 6, it's a product of tangent and secant or cotangent and cosecant. So in here, so there are actually 4 cases, no, or possibilities. Okay? Pero yung dalawa magkasama na. Okay? If m is odd or even, and then n is even, so we use this transformation. No? So we subtract 2, okay, so from the secant, so para magkaroon tayo ng secant squared. Okay, so para magkaroon tayo ng secant squared. And then, ganun din sa cosecant. It's still the same thing. And then afterwards, actually, this is the same as case 5. So yung pinalitan natin or sinubtrakan natin, so yun yung papalitan natin ng 1 plus tangent squared. And this case, it's the same as case 5. Okay? So when n is even, okay, so when n is even, and then tangent, for the tangent, so whether that is positive or whether that is odd or even, basta as long as secant is even, okay, so that is the same as case 5. The second one is when both m and n are odd. Okay, so when m and n are odd, this time, ang magiging derivative natin is yung secant u tangent u. So remember, we have the integral of secant u tangent u du, which is secant u plus c. Right? So kaya pag nagpa-power formula tayo, ang differential natin would be the secant u tangent u. Hindi kamukha nung sa case 5 kanina, so we are using the differential secant squared. So but when both are odd, okay, so for tangent and cosecant, or for secant and cosecant, then we use the differential secant u tangent u. But then when m is even and then n is odd, again, so this is beyond our coverage. So we can resolve that one using integration by parts. So we'll have examples like this. So once we proceed with the topic of integration by parts. So we have two examples. So for this case and the case number 2. So for example number 5, so we have an odd exponent for tangent and even exponent for secant. So this is the same as case number 5. Okay? So we retain the tangent. Okay? So we retain the tangent. So tangent to the 9 2x. And then it is the secant that we're going to change. So parang kamukha nung sa case 5. So we subtract 2 from secant. So secant, 4 minus 2, it's 2. So 2x. And multiply it with secant squared 2x dx. And then, so our objective here is, yun nga, so we need to transform this. So by having secant squared 2x, so that is the same as tangent squared 2x plus 1. So secant squared 2x is tangent squared 2x plus 1. So therefore, that is the tangent to the 9 2x So this is multiplied with tangent squared 2x plus 1. So using the identity, and then we retain the secant squared 2x dx. And afterwards, so we distribute this one here, then the second there. So that's the integral of tangent. So 9 plus 2, that would be 11, 2x. Then plus tangent to the 9, 2x. Then multiply it with secant squared 2x dx. So we separate. So this is tangent to the 11 2x. So multiply it with secant squared 2x dx. Then plus the integral of tangent to the 9 2x. Multiply it with secant squared 2x dx. So it's the same as case number 5. So we let our u, so to be the tangent 2x. Kasi nga, its derivative, so what's the derivative of this? So secant squared 2x times 2 dx. So the formula, it's just power rule. So u raised to n du, u raised to n plus 1 over n plus 1 plus c. So we transform that to the integral of tangent. So our u, it's tangent 2x. So n, it's 11. So du, this one. So secant squared 2x times 2 dx. So we are in excess of 2. So therefore, we multiply it by 1/2. Similarly, so we have the integral of tangent 2x. So our n, it's 9. And then its derivative with secant squared 2x times 2 dx. So we're in excess of 2, so we neutralize it by 1/2. So therefore, so we use this formula. So 1/2, so tangent, that would be 11 plus 1, so that is 12, 2x all over 12. And plus 1/2, tangent, 9 plus 1, it's 10, 2x all over 10 plus c. Or simply 1 over 24, tangent 12 raised to 12, 2x plus 1 over 20, tangent raised to 10, 2x plus c. Okay, so that is when tangent exponent is odd and then even yung sa secant. Okay. So what if both are even? Okay. So both are even. Oh, sorry, both are odd. Both are odd. So when both are odd, so ganun din yung gagawin natin. No? Ay, anyway, when both are odd, we subtract 1 on both. So yung sa, ito tayo niyan. So magsusubtract tayo ng 1 sa cotangent, magsusubtract tayo ng 1 dun sa cosecant. And then, ang papalitan natin is the, mamaya na lang. So we have, this is equal to 4. Then we subtract 1 from cotangent. So cotangent to the 4th x. And then I'll subtract 1 as well from cosecant. So to the 4th x din ito. So yung matitira dito would be the cotangent x and the cosecant x dx. So remember, meron tayong integral for cosecant cotangent, di ba? So which is negative cosecant. So ngayon, we want to transform. Okay, so we want to transform dun sa power rule natin. Kasi remember, di ba meron tayong yung derivative of cosecant u, so to be equivalent to negative cosecant u cotangent u du. Okay. So ngayon, we want to transform this one into cosecant. So everything to be in the cosecant. So para we can use the power rule. So to do that, eto okay na tayo dito. Dito sa cosecant to the 4th x. But the problem is the cotangent to the 4th x. Okay? But then we don't have the identity for cotangent to the 4th x. So what we have is cotangent squared x, then raise it to 2. Then cosecant to the 4th x, multiply it with cot. I'll interchange this now. Kasi usually what we know is the cosecant x, cotangent x, dx. And then, so we have the identity. So for cotangent squared x. So for cotangent squared x, that is cosecant squared x minus 1. And that is what we will be doing here. So we replace the cotangent squared to cosecant squared x minus 1. Then square it, cosecant to the 4th x, and multiply it with cosecant x, cotangent x dx. And then we expand. So this the expansion is cosecant to the 4th x minus 2 cosecant squared x plus 1. Then we multiply it with cosecant to the 4th x, multiply it with cosecant x, cotangent x dx. Nga ba, no? So then we distribute. So I'll distribute this one to the 3 terms. I'll have 4, the integral of cosecant to the 8x minus 2 cosecant to the 6x and plus cosecant to the 4th x. And multiply it with cosecant x, cotangent x dx. But then, our u here is, or so we separate each. So we'll just have 4. So distribute natin. So 4 integral of cosecant to the 8x multiplied with cosecant x cotangent x dx. And pangalawa, 2 times negative 2, so negative 8, integral of cosecant to the 6x multiplied with cosecant x cotangent x dx. And lastly, so 4 times the cosecant, so plus 4, integral of cosecant to the 4th x times cosecant x cotangent x dx. So our u here, it's the same for everything. So that is cosecant x. So it's du, it's negative cosecant x cotangent x dx. So pag nire-write natin to, that's 4 integral of cosecant to the 8x. So ang derivative niya, it's negative cosecant x cotangent x dx. So we're in excess of negative, so that's why magmumultiply tayo ng negative doon. Then minus 8 integral of cosecant to the 6x multiplied with negative cosecant x cotangent x dx. So sobra ng negative, so magiging positive ito. And then lastly, so we have 4 integral of cosecant to the 4th x, so multiplied with negative cosecant x cotangent x dx. So sobra siya ng negative, so we neutralize it by negative 4. So the answer for this one would be negative 4 cosecant to the 9th x all over 9 and plus 8, then cosecant 6 plus 1 is 7 x all over 7 and minus 4 integral of cosecant to the 5th x all over 5 plus c. And finally, we'll have negative 4 over 9 cosecant to the 9x plus 8 over 7 cosecant to the 7x minus 4 over 5 cosecant to the 5th x plus c. And that is example number 6. Question.